I thought you needed God. Convince me. Why are you lying? You don't need the convincing. I gave you the
embarrassing
argument.
for you.
You don't even remember polynomials. You don't want to be convinced.
I read you the definition of what a polynomial is.
Compound ignorance. You see the proof, you deny it. You want to see it from Microsoft. You want them to be the gods. That's what you want, right? You want to see it from Willow. The plagiarizers. Huh, check who did it. Go check ResearchGate. Go. Yalla. God doesn't like you. God doesn't need you. If you need him, he will like you. Period. Bye. Hello.
Layeth, how's it going?
Well, it's going really well.
Glad to hear it. Do you believe in God, Layeth?
Yes, I do. I am a Muslim, and okay. I believe that science and belief at some point, they're not only cross, but they really meet and intertwine.
Okay, great. Yeah, so what would you say is the most compelling argument for the truth of Islam?
The most compelling argument is, first of all, if you hear about the ontological argument, which is not a proof, but is a standalone, closed, kind of axiomatic proof of how a god of Islam, for example, can be true and logical.
Yeah, okay. Do you want to lay it out for me?
Yeah. Well, the ontological proof is linguistically, or in a word description, would say, define a positive attribute that humans could agree on. You will see it in innate behavior of children, for example. Let's say truth. Then take that positive infinity to positive trait to infinity, and you will have an absolutely truthful entity out there. And continue. Go. What is power? It should be positively, infinitely powerful. And it should give you an idea of that evil is limited. It cannot go to minus, like infinite evil doesn't exist in such an axiomatic system. Because the creation is finite. Even if you go like fully evil, you cannot go infinitely evil with an finite.
Then how can you go? How can you go infinitely good?
You can create many, because he's a creative. Creative is an infinite positive trait. You can create many universes. It's up to you.
Couldn't a infinitely evil creator just create infinitely many evil universes?
But why would he do? He's infinitely good.
Well, what if he's infinitely evil?
Choice.
It just seems like you're saying that you can't have infinite evil, but it seems like if I just replace the word good in all of your sentences with evil, then you get the same effect.
No, the thing about the ontological proof by God, for example, it has no inconsistencies. It's completely, perfectly fine. Here's where the issue is.
Not having inconsistencies doesn't mean that the argument is sound, by the way.
Well, it at least shows you there is a logical way to think of God. So this is what his
if you grant the premises, then which you haven't laid out, by the way, like it'd be really helpful if you could lay out the premises. But if you grant the premises, then yeah, the conclusion follows. If it's a valid form of argumentation, that doesn't mean that the premises are true, though.
Yes, this is what I'm trying to pinpoint, is that, okay, we have a separate floating kind of axiomatic system of the ontological argument by Gödel, and we're having completeness 1 and 2 by Gödel, where our algebra...
Hold on, just to be clear, the version of the ontological argument that you've offered is not the ontological argument that Gödel offers. No, it's completely different.
No, the word description of it will go like that.
No, it wouldn't. It has nothing to do with the way that humans perceive things as good. It never says anything about evil.
It has nothing to do with anybody.
It doesn't say anything about any of those. So Gödel's ontological argument has some serious issues. Namely, it defines God to be a good. It defines being godlike to be a good property. And I could pull up the argument, but there's another serious issue with one of its axioms.
Within its axioms, it has no contradiction, and what is what I'm trying to tell you.
The axioms. Look, maybe you're not understanding my point. If you grant the axioms, then sure, the conclusion is true. Yes. But why would I grant the axioms?
This is what I'm saying. This is exactly what I'm saying. And the cutoff, there's like a gap between incompleteness 1 and 2 and the ontological argument.
No, they're completely unrelated arguments, by the way.
Well, yeah, they're very different from each other, and this is where it gets inviting to do the bridge between them. You see.
Wait a minute, hold on. We need to back up. You said that you were going to offer me the strongest argument or the strongest evidence that you could present, right?
Yes.
And the argument that you've presented is a strange version of the ontological argument. But if you're going to say that this is the strongest evidence, then you need to defend the premises. You can't just say the argument is valid and then say, aha, well, that's a compelling argument. Like, that's just not what a compelling argument makes.
I didn't say my argument yet, Dr. Blades. Well,
okay, so then why'd you bring up the ontological argument if that's not your argument?
This is referencing. This is what was done. Previously, this is what was done.
Okay, well, I want to know what the argument that you're offering is. I don't want to hear about other arguments that you're not offering.
All right. So here's the argument. We have you stop me always at incompleteness. So incompleteness too is used actually polynomials, and it shows that even within algebra we will have problems that are unsolvable.
Sure.
Undecidable.
Yep.
Like
undecidable given a certain set of axioms. Yeah.
Yeah, like the algebra itself doesn't matter. Algebra is the core of math. So if you go to even
sure. There are polynomials for whom that we can write down explicitly that depend on ZF or ZFC, and we cannot determine what the roots of that polynomial are within ZFC. That's true.
Yes, for example, a known polynomial that is extremely famous is the Riemann zeta, or the Riemann hypothesis.
That's not a polynomial.
Yeah, it is.
No, it's not. It's an infinite product.
Look at it. It's an infinite sum. You can form it in an infinite product, which is a polynomial. Yeah,
so polynomials are by definition finite.
Okay, what do you call x minus 1 plus x minus 2? That's a polynomial of second degree. Yeah, you can write the Riemann zeta.
That's a polynomial of first degree, but the Riemann zeta function
second degree.
You didn't say x squared, did you?
Minus 1, x
oh,
minus
this is a product. Okay, this is a product. 2. Okay, yeah.
All right. Yes.
Yeah, but that's finite. A polynomial by definition is finite. The Riemann zeta function is not It's not a finite polynomial.
Yeah, it's an infinite multiplicative or infinite sum.
Right, which means that it's not a polynomial.
Yeah.
It's not a polynomial.
But you can multiply. You can write it in the infinite multiplication form,
but
which is
still not a polynomial.
That's a polynomial.
No, polynomial by definition has finite order.
Check it out, please. No,
I can assure you, a polynomial has finite order.
Check it out. What is the solution of a polynomial? Again, it's x minus.
Look, you're just confused here. A polynomial has finite degree, finite order. You are.
Okay, tell me what is a polynomial, solutions wise.
A polynomial is. I mean, we can describe it.
Go. That's zeta. It's infinite.
I didn't even answer the question.
Go ahead.
Be good faith. So the way that you can intuitively understand a polynomial is some finite sum of some number of powers of variables. So you could have any finite number of any finite power, integer power of variables, composed with addition, subtraction, multiplication, and that's it.
Yeah, if you allow me, I will open my camera
over some field.
Yeah, I will talk with math, on a board, if that's all right.
I can't. I won't be able to see any of this. Look, a polynomial has to have a finite number of terms. It doesn't seem like it's super relevant.
It is.
But what's the actual? Can you actually present the argument?
Why are you struggling with me to let me finish a sentence?
I just want you to present the argument.
I'm trying.
Okay, please do it.
Swear to God, voila. Okay, now we have a third degree polynomial will be x minus a times x minus b times x minus c. So an infinite polynomial will be x minus a with subscript I, with the multiplication goes from 0 or 1 as you choose to infinity. How you define your coefficients. Now,
that's not a polynomial.
That's zeta. That's a polynomial within the solution form.
Okay, hold on.
What the hell?
I guess I just have to show you this.
Yeah, show me that.
Okay, can you see this? This is Wikipedia. I'm sure that Wikipedia is fine because definitions of a polynomial are fine. In mathematics, a polynomial is a mathematical expression consisting of indeterminates, also called variables, and coefficients that involves only the operations of addition, subtraction, multiplication, and exponentiation to non-negative integer powers and has finite number of terms.
Yeah.
The Riemann zeta function is not a polynomial. It doesn't have a finite number of terms.
The infinite polynomial.
There are no infinite polynomials.
Write it down. Why did you stop at polynomial? That's it. That's a polynomial. I'm talking about the infinite polynomial.
Polynomials are by definition not infinite. Like.
Right. Hold on. You will not
Why are you fighting on me? This is like a standard definition.
Well, you're denying it. This is probably the worst case of denial I've ever seen. I know.
Yes, I'm denying the standard definition of polynomials because you think that the Riemann zeta function is a polynomial.
You can define it in many ways. What is a polynomial? It's a group of solutions multiplied by each other. So why are you?
No, that's not what a polynomial is.
All right.
A polynomial is a particular finite set of operations combined or composed together. Like, that's what a polynomial is.
Well, this is a polynomial, right? Let's say 6. Okay, this is a polynomial.
Yes, that's a polynomial.
Right? You agree with me, right? So what is this? Plus 2.
By the way, I swear, if this isn't relevant, if whether or not the Riemann zeta function is a polynomial is not relevant for your argument, I'm going to drop you.
Are they the same or not? Not the same, but
I can't really see them. They're small and blurry.
Well, some coefficient here, a. All right, this is x squared.
X squared plus 6x plus a.
Plus a.
And then they're obviously not the same. One depends on a, the other doesn't.
You can factor a polynomial or not. You're being an asshole right now. Can you factor a polynomial this way or not?
Of course, you can always factor. You can always factor a polynomial through its solutions. That doesn't mean that it can be infinite.
A third degree will have 3 terms, right? 3 terms.
Yes, and that doesn't mean that you can have an infinite number of solutions.
An infinite.
I muted you, by the way. This crash out is wild. Like, this is just like a standard definition of what a polynomial is. There are no infinite polynomials.
Faking science. You're faking science on live now.
This is like a crazy crash out. Like, just open up a standard algebra book.
You know what is a polynomial.
Yeah, a polynomial is a finite order object.
See how we look like? This is how we look like. You look like a fool.
This is a crazy crash out. Hi, YouTube.
So we don't know.
I'll see you guys on YouTube.
Anymore? You don't know a polynomial anymore? You don't know? You forgot?
Sorry, I'm just writing this down.
Yeah, just cough. Finish coughing.
No, I wasn't coughing. I was laughing. Yeah. So does this have anything to do with God?
That is how I teach my kids, by the way. Okay.
Does this have anything to do with God? Yeah, I already read you a definition of a polynomial.
Yes, it has. You can write axioms in polynomial form too. How about that?
Sure, I'd believe that.
Why? It's not a polynomial, right? Then you can write axioms in zeta form.
So you can express essentially, as long as you have a dictionary for how to identify what certain symbols mean, you can often express any proposition as a polynomial. Like, that's a thing that's, I think actually Gödel came up with that.
Alhamdulillah. So Riemann zeta could explain the axioms in infinite form.
The Riemann zeta is not a polynomial. We've been over this. The Riemann zeta function is not a polynomial.
I'm not over this. You're really scandaling yourself. I can't believe it. You're a doctor.
Do you need me to open up a textbook showing you that a polynomial has a finite number of terms?
Write it on Google, infinite polynomial. I'll write it for you if you want.
Here, let me just open up a textbook for you.
Write it, infinite polynomial. Just write it.
I'm actually not going to do that. Instead, I'm going to open up a textbook for you.
Okay, go ahead.
Actually, do I have my abstract algebra textbook? If I do, then I don't need to go download it. Let's see.
Don't download anything. Just use Google like you did with the other one.
Well, no, I know. I'm trying to pull up a textbook for you so that you can learn what a polynomial is.
Oh,
because apparently you need to learn what a polynomial is.
I needed this scandal to show that actually atheists just deny God, even when it's in front of them. They will deny that what is a polynomial. I don't know what it is.
Okay, so I don't have my abstract algebra textbook, but we can pull up this. We can pull up this book. This is a book by Beauregard. Yeah, by Raymond Beauregard and John Fraley. We can pull up this book. We can see if we can find a copy of it.
I'll make it short for you. Just open the Lagrange program, okay? And see what it does with physics and what does it have to do with God.
Sorry, are you going to make your argument or no?
You don't know what is a polynomial. What argument about?
I can assure you I know what a polynomial is. Okay, let's go to page 153.
All right, so...
We're going to page 153, don't worry. Oh,
go ahead.
Never mind. I don't have access to this book. It's not freely available.
Well, I have access to this website, and it's we can agree it's a good one. It's called LibriTexts, so it has a book.
Yeah. So definition of, why don't we just do this, of polynomial?
Infinite polynomial. Why
type
are
that
you
into
mixing
Google.
This is a different term. Oh, this is a play with game with words. I swear to God, I can't believe it. I thought you would have a real discussion. Yeah, I don't see that. This is not a real discussion. Polynomials, there are two things. There's polynomials and there's infinite polynomials. Two definitions.
So we agree that the Riemann zeta function is not a polynomial?
All right, what is the Riemann zeta function? Do you know what it is?
It's an analytic function. Well, I guess it's meromorphic because it has poles.
Yeah, is this the Riemann zeta function? In
it's hard to see. It's hard to see.
Yeah, can you just...
So the Riemann zeta function is a meromorphic function. Now, look,
I'll copy it here.
Is this going to have something to do with God, please?
Yes, axioms.
Okay, can you make the argument then? Can you just present the argument, please?
Yeah. Okay, so here's the argument. I'll make it easy for you. Okay, sorry for shouting at you. Sometimes under pressure you forget what are things. It's all right. It happens even with me. Now you can write. This is the multiplicative thing there. Okay, so you can write axioms in this form, where lambda is the operator. You see, it's an eigen problem now. It's a polynomial. Now this is a polynomial, and you can write it from 1 to infinity. It will be an infinite polynomial. Now what is this? This is also the
You can just call it an infinite product if you want, by the way.
Yeah. This is the Riemann zeta. You can write it in this form where lambda equals 1. Okay, that's Riemann zeta. Now, to show you a reference for that.
Wait, no, that's not the Riemann zeta has a different expression. But anyway, no, okay, actually it doesn't matter. Sorry, I'm not going to get bogged down. I'm not going to get bogged down in your mistakes. It's fine. Make your argument.
No worries. But anyways, you can write Riemann zeta in this form. You can find what is lambda. I thought it's 1. Maybe it's something else. Good. It's something else.
Yeah, it's something else.
All right.
But go ahead.
All right. But this is the Riemann zeta, and it is the infinite polynomial. They're the same thing. All right. But you have to change lambda. Okay, now this one also you can describe with the z and the lambda and another coefficient maybe here. You could really put your axiom system, like let's say Aristotelian logic, formal logic, or informal logic too, by some manipulation of this. Okay, so
what's the argument for God?
Somewhere here. Yeah, you can express the ontological proof here. And the infinite positives, you can express them with algebra itself. Now, what is incompleteness is when you have a finite polynomial, because it tells you have to be able to read the code or the algorithm that you're reading to be incomplete.
No, you can have finite polynomials that still don't have known solutions under a given set of axioms.
That's all right.
No. I mean the incompleteness theorem. The incompleteness theorem has nothing to do with polynomials being finite versus polynomials being infinite, even though there are no infinite polynomials.
Yes. This is where the extension comes. Incompleteness theory tells you from its polynomial proof that there will be polynomials you cannot solve because you have more than 5 degrees and other.
That has nothing to do with incompleteness, by the way.
Really?
Polynomials of not being able to. Yeah, that has to do with Galois theory.
Sorry, this is called incompleteness theory.
No, that's not called incompleteness.
It has to do with Galois. Okay, it has to do with Galois.
That's Galois theory. That has nothing to do with incompleteness.
The group theory has to do with zeta, and zeta has to do with infinite polynomials. They are all related.
So the lack of ability to solve algebraically for some quintics has absolutely nothing to do with Gödel's incompleteness.
Yeah. What if it was 6 degrees? Can you solve it analytically?
It's true for any degree, or it's true for some polynomials with any degree greater than or equal to 5.
Do you have an algorithm for solving a 6 degree?
I'm sorry, did you hear me?
Predict an algorithm.
I'm sorry, did you hear me?
Yes, I heard you. But
okay, what did I say? Because I answered your question.
You said this 5 years can solve it, whatever. But 6,
no, you didn't hear me then, because I didn't say that. I didn't say that.
Yeah, can you predict an algorithm? All right, go ahead, say it again.
Yeah, so what I said is that for any polynomial or for any degree greater than or equal to 5, there are going to be some polynomials that you cannot solve using strictly algebraic means.
Yeah,
you cannot solve it through roots and through other algebraic expressions or algebraic operators.
Yes,
that has nothing. That has absolutely nothing to do with incompleteness.
So any algorithm you have will not be decidably giving you a solution. In
no, it has not. To be clear, this has nothing to do with decidability. This has nothing to do with any of that. This has to do with algebraic solvability. You can absolutely construct an algorithm. Okay, I have to mute you again because this is just this is embarrassing for you. There's absolutely an algorithm that you can use to find the roots of any polynomial to any degree of accuracy that you want. However, it just does not necessarily. For polynomials of degree 5 or greater, you can't necessarily express an algorithm that involves only the 4 fundamental operations plus minus multiplication and division, exponentiation, and sorry, not exponentiation, and root and taking roots. Those are the only. It's just for degrees greater than or equal to 5, your algorithm must include something extra beyond that, but it has absolutely nothing to do with incompleteness.
Listen, God doesn't need people. People need him. In the end, if you believe a polynomial or not.
What's your argument for the existence of God?
I'm saying that if you feel that God needs you, he doesn't.
That was your argument this whole time? You wasted... How much time did you waste? You wasted 20 minutes going on and being wrong about polynomials and Galois theory, only to say God doesn't need you?
Well,
that
I'm
was
wrong.
so embarrassing for you.
God. I thought you needed God. Convince me. Why are you lying? You don't need the convincing. I gave you the
embarrassing
argument.
for you.
You don't even remember polynomials. You don't want to be convinced.
I read you the definition of what a polynomial is.
Compound ignorance. You see the proof, you deny it. You want to see it from Microsoft. You want them to be the gods. That's what you want, right? You want to see it from Willow. The plagiarizers. Huh, check who did it. Go check ResearchGate. Go. Yalla. God doesn't like you. Doesn't need you. If you need him, he will like you. Period. Bye.
There's the crash out.